This resource is the third in a series on derivatives. We will explain the concept behind derivatives and formally define them. We will discover how to find the derivatives of various forms of functions, including polynomials and trigonometric functions. We will consider how to differentiate products, quotients, and composition of functions. We will also consider applications for derivatives and how they relate to real-world situations. In the previous resources in this series, we discovered the formal definition for a derivative and also how to find the derivative for a polynomial function. This resource will use the formal definition to discover the derivatives for sine and cosine. Recall that the formal definition for the derivative of a function is the limit as h approaches 0 of the quantity given by the function evaluated at x plus h minus the function evaluated at x divided by h. In the development of the derivatives for sine and cosine, we will need the angle sum formulas for those trigonometric functions. The sine of the quantity a plus b is equal to the sine of a multiplied by the cosine of b plus the cosine of a multiplied by the sine of b. The cosine of the quantity a plus b is equal to the cosine of a multiplied by the cosine of b minus the sine of a multiplied by the sine of b. Now that we have the background information we need, let's develop the derivative for sine. To begin, we have the function f of x equal to the sine of x. The formal definition for f prime would be the limit as a approaches 0 of the quantity sine of x plus a minus the sine of a divided by a. Note that there is a function denoted SINH, which is the hyperbolic sign. To avoid any confusion with this function, we change the notation from h to a. We still are looking for the function value a small distance from the desired point and allow that distance to go to 0. Using the angle sum formula, we have the limit as a approaches 0 of the quantity the sine of x multiplied by the cosine of a plus the cosine of x multiplied by the sine of a minus the sine of x divided by a. We can rearrange the terms so that terms involving the sine of x are written together. We can also split those terms into separate limits. We are left with the derivative equal to the limit as a approaches 0 of the sine of x multiplied by the quantity cosine of a minus 1 divided by a plus the limit as a approaches 0 of the cosine of x multiplied by the sine of a divided by a. Because the sine of x and cosine of x are independent of the choice for a, we can factor them in front of their respective limits. We are left with f prime of x equal to the sine of x multiplied by the limit as a approaches 0 of the quantity the cosine of a minus 1 divided by a plus the cosine of x multiplied by the limit as a approaches 0 of the sine of a divided by a. Both of these limits are in indeterminate form, so we will see if we can find the limit graphically. If we simply take the limit as a approaches 0 of the cosine of a minus 1 divided by a, we get a situation where we have 0 divided by 0. However, these indeterminate forms can sometimes have defined limits. Let's take a look at the graph of this function. Notice that the graph approaches a single value as we approach from the left and from the right. This means that the limit can be defined. We find that the limit is, in fact, 0. We also have an indeterminate form for the limit involving sine, where we would have 0 divided by 0. Again, we need to look at the graph of this particular function. The graph clearly approaches the same value from both directions. So the limit as a approaches 0 of the sine of a divided by a is 1. Now we can finish finding the derivative of sine. We had left off with f prime of x equal to the sine of x multiplied by the limit as a approaches 0 of the quantity the cosine of a minus 1 divided by a plus the cosine of x multiplied by the limit as a approaches 0 of the sine of a divided by a. Since we found those limits, we can proceed. Taking the limits, we are left with the derivative of sine equal to the sine of x multiplied by 0 plus the cosine of x multiplied by 1. Therefore, the derivative with respect to x of the sine of x is the cosine of x. Suppose our function is f of x equal to the cosine of x. Per the formal definition, f prime is equal to the limit as a approaches 0 of the quantity the cosine of x plus a minus the cosine of x divided by a. We use the angle sum formula for cosine to realize that the derivative of cosine is equal to the limit as a approaches 0 of the quantity the cosine of x multiplied by the cosine of a minus the sine of x multiplied by the sine of a minus the cosine of x, all divided by a. Rearranging and splitting the limits as we did with the sine, we have f prime of x equal to the limit as a approaches 0 of the cosine of x multiplied by the quantity cosine of a minus 1 divided by a minus the limit as a approaches 0 of the sine of x multiplied by the sine of a divided by a. Moving the independent functions to the fronts of the limits, we have cosine of x multiplied by the limit as a approaches 0 of the quantity cosine of a minus 1 divided by a minus the sine of x multiplied by the limit as a approaches 0 of the sine of a divided by a. Taking the limits, we have f prime of x equal to the cosine of x multiplied by 0 minus the sine of x multiplied by 1. Simplifying, we find that the derivative with respect to x of the cosine of x is the negative sine of x. To recap, the derivative of sine of x is the cosine of x. The derivative of cosine of x is the negative sine of x. We may be curious about the derivative for tangent, secant, cosecant, or cotangent. Unfortunately, the derivatives for those trigonometric functions are more difficult to determine and require additional information. However, we will find those derivatives in a future resource in this series.